Right. So last time I presented the general information, so I'm not going to go through them, but just for your information, we briefly discuss about the course conduct and the main topics. And after that, I explained the aim of the course is give you understanding about how the software is designed, and the designing a software is a huge project, a complex project. So how we are going to manage it? So the tools and techniques available for design and technique will be covered in this session. And once you complete the course, we'll expect you to have a good understanding about the software development lifecycle. Traditional waterfall, which means the traditional structured analysis, you should have understanding about what are the phases and what happens. And then also like the newer trends like agile and DevOps. So you should have a good understanding about these techniques. And the next one is the newer software development. We always focus on users because users are the customers. Without user, we will not have anything in the development. So we always have to get the user oriented approach when we are designing software. And then also you have to have understanding about outsourcing, especially in any organization. You are not going to develop everything in-house, which means sometimes you have to get the third party. You can request third party for designing software for you. So there are like different ways that you can actually get the help of a third party. So we will discuss this under outsourcing decision. And then the main focus will be the different software development approaches. And today also we are going to focus on agile. I'm going to talk about Scrum and Kanban, for example, where we will try to understand there are different development approaches out there, and depend on your requirement, you might use one of them. And then what is the philosophy under this particular development technology, and what are the tools and the processes out there, and what are the advantages? These things we will be discussed, and you should have a good understanding. And then software auditing, especially when you have a computer system in an organization, how people actually use or interact with the computer system. So for that, we can done with the auditing in software design. And so that part we will discuss. And finally, we will also discuss design principle for efficient software development. Right. Okay, so last time we discussed we started by looking at the software development life cycle. That is, means traditional software development life cycle we had, starting from planning, analysis, design, implementation, and security and support. So these phases we discussed in our previous discussion, and so-called we have 5 stages in this particular case, and each of these 5 stages we have different outcomes. So we need to understand what processes are there inside each of these phases. So I told you in the last session that we normally start with the planning stage. In planning stage, we'll start with a particular idea, but then you have to look whether it's feasible to develop or provide a software solution for that particular idea. So that is a starting point. So you have to think about the technical feasibility, you have to think about the operational feasibility, as well as financial feasibility, and so on. So when the organization decide that, okay, we are going to go ahead, we are going to have the system, right, then we need to gather required information. So that we will have in the preliminary investigation report. But to get more detailed overview, so you have to have some different techniques to gathering information, And then you have to prepare a document called system requirements documents, which will in detail explain about what features and what component you might have in the system analysis. And then you have the system design. There are different techniques we can use for system design. And then once you finish that phase, we will have system design specification. Then you have implementation. So implementation, after implementation, you will have functioning system. And once you make sure the system security and support, we will have a fully operational system, right? So this, I think we have repeatedly discussed last time as well. So I hope you have a good understanding. Otherwise, I highly recommend you refer our previous notes. Now, if you look back, what is happening nowadays, things are changing rapidly. There are technological changes are there. For example, if you look at last couple of months, there are a lot of AI related tools and techniques were incorporated in software development, which is, I think, we have a drastical shift from traditional software development to recent or modern software development. Things have actually changed. At the same time, we notice there are a lot of limitations of our traditional approaches, especially if you look back the structured analysis where we will things like waterfall model, starting from requirement gathering to delivering a system will take longer time, which means sometimes user requirements has changed. And you can see, if you look at, if you are going to develop a software with the changing environment, especially like today's environment, so the traditional approaches has their own limitations. So that's why if you look at what happens in the software industry nowadays, we have what we call agile and DevOps, which is focusing on different aspects of software development. So always you can see people work on these areas or these with these methodologies. They talk about continuous integration and continuous delivery. That means you will have frequent updates and frequent delivery. And usually you will have pipeline, meaning that they are almost automated. And also working in collaborative, especially in team collaboration. And I told you, like, software development may happen within the 24-hour cycle with the teams in different geographical locations, where once you finish, they hand over their development to another team and so on. So it's not like in our traditional software development, or it's not like what individually we learn in our environment. It's totally different in industry. And the adaptability, and then also emphasis on user experience. I told you, like, we will design based on the meet user expectation. So we have to focus on the user experience. Responsive design. So hopefully you have discussed these things under the web development, for example. And also efficient software delivery, right? So focus has actually shifted from developing one complete working software into developing reusable components or developing frequently changing components. So, right. Briefly, we discussed about agile processes last time. Let me briefly revisit again. So agile processes in general, you will notice that they build on top of the idea of incremental and iterative approach. So which means you will start with a small working version of the software prototype, and then you keep on increasing, adding features and so on, which is what we call incremental and iterative approach. And in agile, the focus will be the collaborative efforts, especially you will have different teams which takes different responsibilities. and they are self-organized, self-motivate, team will work on agile processes. So some examples are Scrum, Kanban, Lean, and there are many others like this, but I think I'm going to briefly touch on Scrum and Kanban at least, which we will see that most commonly used agile processes. So by using agile, we will also get a lot of benefits. One is, I told you the environment is changing. We will have a lot of competition. New feature requirements are evolving. So rapid and flexible response to the change is a must. And that can be accommodated using agile, way of looking at all the development of software. And also, for example, in agile, I will talk about the processes today. So in agile process, usually there's a user involvement and you are getting actually feedback, which means every sprint or every 2 weeks to 1 month's time, there could be possibility to get user feedback, which is known as continuous user feedback. Then the other benefit is you will always get functional software. You will deliver functional software frequently. I told you, like with the agile concepts, now you see software updates comes in every week or every month or every 3 months time and so on. That means you will get frequent updates. The next software development methodology which we will talk about a lot today is DevOps. Especially, it's bridging the gap between the development and the operations. And then you can have a pipeline approach where you can have automated development and testing. Everything is actually put together. So, and it uses a lot of software tools, which I will discuss later on. So, for example, there are a lot of tools nowadays we will use. For example, I hope you know about Git and GitHub. So these tools we will use, especially the code as a code repository. At the same time, this could be used for team collaboration. So likewise, there are many tools that we could use, and DevOps, you will notice that there are a lot of tools available for you to develop software system. So if you look at the key practices of DevOps, and in DevOps, always we talk about the continuous integration and continuous delivery and deploy. So the advantages you will get is you will have faster delivery of features. Maybe you can have features for every 2 weeks time or months time and so on, where for a shorter period of the intervals. And then you can also develop software for different environment. For example, we know that when we want to develop a piece of software, there could be like different operating environment, like operating systems, for example, Windows, Linux, and Mac OS, always in mobile, operating systems. So we will talk about a topic later under the software design called software design patterns, where you can see there are common patterns you will notice when you develop software. So you have to cater these different operating environment, and we can use design patterns when we develop the system to handle these common situations. And importantly, the benefits that you will get from this is you will have improved collaboration and also the communication. Right. Any questions up to this point? Right. I didn't receive anything in the chat, so I hope you have understood what we have discussed so far. There are many other development methodologies out there, although we are not going to talk about in detail. Now, what I have listed is very traditional ones. If you look back early days, after the waterfall technique, we started looking at iterative development. Or sometimes we also said this is called prototyping. So in that way, we can actually iteratively develop instead of working in a full cycle. You can have a deploy, or you can design smaller component and iteratively go through the same step as earlier. And then rapid application development is another area where people started looking at uh, uh, reducing the time it takes to develop the piece of software. So then we have rapid application development, incremental model developments. Incrementally, you can work on improving the features. Joint application development, JAD, is also another way of another development methodology. Reverse engineering especially got popular, especially when you have a system and then you want to recreate. So one way to do is you can actually go for what we call reverse engineering. So the main point in re-engineering is like business goals actually change over the time, and software also must change according to these changes, right? So in reverse engineering, instead of you build from scratch or from the beginning, right, you can actually use existing system. And re-engineering is another one, which we call it, where we can use again existing systems when we are creating a new system based on the previous ones. Then next common thing that we will discuss, apart from the newer trends, object orientation, especially the use of object-oriented principles and object-oriented programming languages. So use these as development methods. Right. The next thing that I would like to discuss is actually system design part. But before we discuss about the system design part, we have to talk about what will happen in the previous stage. For example, we start with the feasibility, and I told you we have technical, organization, financial feasibility before we decide on developing the system. And then there's the main role played by, when we are deciding on whether to develop a system, is cost benefit analysis, which we will discuss, where we will focus on how costs are calculated and then how you measure the benefits of using this piece of software, right? And then you will have different information gathering channels where you actually think about what features that users are expecting. So you can have a list of features, and then this will be input to the next stage where when you are designing. So design, as I told you earlier, there are many ways that actually you can use. One technique that we could use is compared to traditional development is use of object-oriented principles, where we have things called objects, the properties, the methods, and the messages. So again, when we look at an object-oriented way for a problem, we have to start looking at with the object-oriented principles like classes, and how classes can be used to generate objects, and how we actually model the object interactions, and how message passing could be used to increase the interaction about the different components. Right, now here are like some of the ideas that actually we discuss on the object orientation. By the way, what is the right in object-oriented analysis? You create the blueprint or basic structure is we call classes. Now, for example, in this figure, what you see is we have a person, and then that is our class, and then sometimes we call this is a parent class, and then we have child classes, two child classes. We will have instructor and the student. Then we talk about things like inheritance. Uh, student, I told you this is the child class. Child class always inherit everything from the parent class, right? So in our example, we can see there are three properties in a person class. We have name, address, and date of birth. So what happens when you create subclasses? So all the attributes available in the parent class will be available with child class as well. So both student and instructor, now you will see the same properties. And then there could be like related other properties as well. For example, student, you can see here GP and advisor, which is only relevant for those students, but not for instructor. But of course, you can see instructor is also having other properties like office location, office phone, and email. So which you will have two different classes. Right. And during object-oriented model, it works as iteratively compared to waterfall model, where you start from somewhere and you complete each phase until you reach the last phase. But this could be more iterative, work in iterative fashion, where you will have planning, analysis, and design phases, works like that. And then you can actually create small piece of software, which we call prototypes, and then testing them. Right, now let's, that's the traditional software development and OOP. But now, if you look at what is happening nowadays in software development, you can see a lot of agile technologies, as well as we discuss things like agile methods. So basically, what will happen in agile world is it's not like in early days, the user requirements are changing over the time. So that's why the agile methods came into the picture compared to traditional waterfall model to handle the limitations of the structured development life cycle. So main thing is in agile methods, in commonly, they try to develop the system incrementally. And then you are building a small piece of software, which we call prototypes. And then you actually consistently change them based on the user requirements. Right. And then usually these methods use a spiral model, which means you will have several iterations, revisions, based on user feedback. Right. So most commonly used agile technologies I would like to discuss very briefly today. One is Scrum, and the other one is Kanban. Actually, these two, agile technologies originated in different fields. For example, originally, Scrum is actually for software, but Kanban is actually came from the manufacturing. But later, it is adapted to the software development. So, but both actually focus on develop the system incrementally and continuous, continuously you actually accommodate user requirements. Right. So let's talk few things about the Scrum. So Scrum actually came into the picture right around like 1980s, sometime back. I guess about now it's about like 40 years where the Scrum originally came. And then this actually focus on the new software product developments, and especially the name Scrum came from a game of the rugby, right? Okay, and now the use of this Scrum technology came to the picture around like 2000. So the original idea came around 1980s, right? And then the focus of this Scrum is basically uh, making how the system works for the changes, and we want to maintain the productivity, especially the productivity of teams, and I will come to that point. Now Scrum usually works as a teams, and you will have delivery life cycles which we call sprints. You can see the term, which is like 2 to 4 weeks. So iteratively they are going to develop. So with this process, what has happened, it's actually, there's a process that we discuss, and the process is very transparent. So there are specific phases in the Scrum methodology, right? So um, so basically, when you start with the Scrum, there are few things we need to focus on. Usually we call, there are 5 time-based activities or time-based things, starting with the sprint planning stage. Now, the sprint planning stages, they normally call it's around like 8-hour session, and then teams get together that talk about how to deliver and what to deliver with the product backlog. It's product backlog is something like you have a set of features and you are going to decide in a meeting. We are like what to what and how to deliver that. So there will be a planning stage they work on. So now once they decided on what to implement, they are for the implementation cycle. That is cycle usually we call sprint, and we will have set of features the team is going to decide, which we call the sprint backlog, and then they are working on 2 to 4 weeks interval. We normally call 2 to 4 week sprint. Now working, it's not just they work on 2 to 4 weeks on the features in the sprint backlog, but there are some what we call daily Scrum meetings. We have the team meets daily, especially to look the progress and identify any issues. They use the term blockers there, and so that's how they actually work on, right? So for example, in each of these meetings, they might ask like what features you are about to implement and how to implement, what are the issues. Things are actually sorting down during the daily Scrum meeting. So that usually actually represented here. So you start with a set of features, and during the sprint planning, you decide on a couple of features for particularly time interval for 2 to 4 weeks time. And during 2 to 4 weeks time, they daily meet, which you call daily Scrum. Now, once you finish this 2 to 4 week sprint, once they finish that, so they'll meet again, and then usually team will demonstrate or show the changes to their customers, and then they get the feedback, right? So there are two things could happen. One is like getting a feedback on what they have implemented. The second one is like what features that they are going to implement next. So this is normally they call sprint review, right? And once they have finished, they have another, session which called sprint retrospective, which means again after the sprint review and before their sprint planning, right? They discuss about their work. They look for improvement, and especially for the next cycle, right? So these are the usually how Scrum works. So you can see in uh, Scrum, you have some uh, uh, ways that, oh, you have some phases that you have to follow. So even in when you want to develop some piece of software, you can adapt the same. Similarly, like once you decide on what features that you are going to have in your system, so you as a team you can decide a couple of features for a smaller time frame, and then daily meeting and getting and reviewing your work, actually basically the focus for Scrum. Now now although we talk about some the roles here, we need to discuss some roles, specific roles inside this Scrum. So usually there should be some what we call product owner. That means a single person who's actually taken care of what we call the set of features or the product backlog. And then you have to have a Scrum master. That means you have a leader which actually makes sure that you follow these set of uh, steps, rules, whatever the practices. And then you will have a development team, right? So that's how it works. Now the next thing is, if you ask me like how are you going to measure the success of this, or in other words we can talk about the metric of Scrum. So main metric for Scrum we call velocity. Velocity means the progress rate. So what? Okay, so that it's like this, like you take two features and you decide on implementing, let's say 2 weeks time. So depend on what they have decided in the beginning, that they can actually see how successfully they have delivered the product, right? Okay, and then so these are the main things that actually we can talk about the Scrum methodology, which again actually you can see that when you deliver, you can always monitor because you have daily meetings where you can find solution immediately without wasting developers' time. Okay, the next thing that I would like to discuss is what we call the Kanban, which is you can see the diagram here. I will explain what this is. Kanban actually originated earlier than the Scrum, and then this mainly the use of the Kanban. The word is actually in a Japanese name. The kan means the sign, and the ban means the board. Actually, basically, the term actually reflect into signboard, right? So they talk about this is actually tracking what their the demands for the work. So you can see here in the graphic that we have what we call swim lanes, where we have separate lines. So these are actually work assignments, and uh, and these are the work in progress, and these are the ones actually completed. So it's actually visual, like like a board where you can actually keep track of. And the point that they are going to have is the visibility, right? So the visibility, they know like what features are, being developed and tested, and what are the features actually deployed and so on. So this is a clearly different way of looking at it, right? So, for example, so it's Kanban is actually, they say it's to improve the system through visualizing their work, especially their work in progress, right? So the idea is they say, okay, you start with what you do right now, and then you agree on, particular change, and then you are trying to finish, and you are trying to limit number of existing work allocated for you, right? So like in Scrum, Kanban also have some phases. Actually, they talk about six major practices, and not phases, actually practices. The first one is they visualize the flow of the work, which means you can visualize exactly like the image you can see here. Uh, Sometimes they use cards, or sometimes they actually use piece of software to do that. The second practice that actually they talk about here is, okay, you should limit work in progress. So that means when team, let's say you are working on a particular feature, so what is recommended is you should finish that feature before you take another, work assignment, right? So, so you can see there are some numbers here. Build, there are 4, test is 3. That means how many, work, let's say, are going to keep it here, right? And then once you have the visualization, it's always easy to manage the flow. You can observe what is happening. Where are the blocking stages? Now here you have 2 places. They have blocked due to various reasons. So you actually have a good understanding of the process, right? And then you have to have some policies how to actually, process, evolve within this uh, within the board, right? And also ways, once you actually complete, you should get the regular reviews. So that reviews actually may come from the team, or maybe it can come from the customer. And then with that comes as the feedback. And the last one is we can talk about the improve collaboratively, evolve experimentally as a team. We can improve the initiatives, and then you can work on the changes experimentally. Right. Okay. So like in velocity in Scrum, in Kanban, focus on, there's no roles like in previous case, but there could be 2 rules actually. Later on they talk about service delivery manager and service request manager, but the main focus that is like in velocity for Kanban is cycle time. That means how much time a particular task, the work, spent going through the process, right? For example, how long it will wait here until finish, how many days, for example, right? So you know that when you have finished one, so you first start with the ready, and then once you get free slot here, it will come here. So that means here we have parallelly we have 4, and then we have 3 testing, and this is the deployment, right? So the cycle time is how long it will take, or it will stay in this WIP limits that we can look at. And then the second one is what we call the throughput, which is the total amount of work delivered, right? So that's how the Scrum and Kanban ideas were there. Basically, you can see you have a process which, if you adhere to, which will improve the software development. Right. As I told you earlier, there are many other methods which I'm not going to go into detail. And these are like quite old techniques, but still some of the companies are practicing them, and you should know how they work, right? But one thing is very important, irrespective of what development strategy you are using, is it object oriented, or is it Scrum or Kanban, right? We have to efficiently manage our resources. Like in this particular case, we have to manage, effectively manage the project deliverable, because you have to have a rough idea how long it might take and what other the activities actually delay or main course for the project to be successful at the end. Right. So now I think this is actually in brief we discuss. Some of them actually we are going to discuss more in coming sessions. So that part, with that part, we conclude about software development. So let's briefly look at the software testing part, which is again very important area where you make sure that there's no bugs in the code. So when you look at software testing, so traditionally we use debuggers or like code reviews. Still we use, but mainly we have very traditional way of testing software, but things have actually changed, right? Because I told you, with the change of the technology, now with the change of technology, you have a different set of problems. And I told you, like with the new agile and DevOps methodologies actually change how testing is done. Early days, we can test this thing separately, but nowadays we'll focus on automating this. So therefore, we always talk about continuous integration, continuous deployment. These things actually automate testing and deployment. When you say testing, one thing is you can test in your own environment. We call containerization. I hope you have heard the word Docker, which means now, for example, let's say you develop some piece of Python code, and when you develop some application, you have to maintain their versions, and some, when you use especially some modules, a particular version you need to use. So the problem is, now once you test the system, it might work in your computer, but when you send it to somebody else, when you host somewhere else, and when people try to use them, then they might get errors depending on how their systems are configured, or how or what software systems that they have installed. So therefore, the container, which like Docker, which it makes sure that you will have the same environment. So once you containerize, so you will have the same setup as in the originally with the developer, right? So these things actually becoming popular in modern software testing. If you look at some types of testing, the traditional testing types, we know unit testing, integration testing, system testing, adaptive testing, and so on. So these are like very traditionally what the testing the types are. But it's still the unit testing, once you write a code and then you test that piece of code, that is very fundamental. And then we can use different frameworks for this. Once you do the unit testing, then you have to think about how you are going to integrate these things together. And to check that, we have to have what we call integration testing. Then if you look at new trends today, nowadays we have even like GUI testing, like Selenium. If you use tools like Selenium, you can check the GUI and you can automate them. Then because of we have a lot of security concerns with the hackers and so on, so we can also have security testing because now we have a lot of increasing cyber threats are there. Then performance testing, especially let's say you have a website where you want to check the performance. So one way is you have to look at how many users that actually can log in and work in successfully without the failing the system. So kind of testing we call performance testing. So we can use software like JMeter or Gatling, which it can generate high loads. Of course, with the new addition of the AI powered testing is getting most common, and especially software testing could be automated with these tools. So one way is use of machine learning to identify test cases and predict the issues. Okay, next. We have to talk about the quality assurance as well as modern testing tools. Now, quality assurance is actually part of the software development. Sometimes the same team play the quality assurance team as well. And some other places, they might have their own dedicated QA team, right? So now for quality assurance, there are a lot of tools and techniques are used, so they can look for efficiency and accuracy. So AI and machine learning especially can be used to anomalies and any issues, or there are like test automation frameworks which you can actually use. Then containerization, again, we have to make sure that the developed environment will be the same when it actually used by the users. Cloud-based, especially nowadays, the software, we mainly focus on the cloud environment, and then we have to test and the resource requirements. And last one is collaborative platforms, especially when software development comes, different people use different technology, interact with each other. Jira is one such platform where collaborative will improve with these tools. Right. Test planning in agile environments, agile methodologies, we already discussed, promote continuous testing to development. And we can use what we call test-driven deployment and behavior-driven development to ensure these test guide development. And test plans are more dynamic, adapting to evolving requirements, and testers and developers usually collaborate closely in agile teams. And user stories and the acceptance criteria actually define the test cases. Okay, before we move on to next part, I will take a 5 minute break. What we have discussed so far is the different methodologies that we will use in software development and what metrics we will use. So the next two things that I would like to discuss is standards that we want to maintain, but now is 11:05. Let's meet around like 11:10 to the second part of the session. Okay, so in this part, we are going to briefly discuss about the industry standards and matrices used for development of software. So basically, like in any product development, like in manufacturing, you might have seen there are some standard. Similarly, in software industry or IT industry, or also we will have some standards. So some key organization and standards, ANSI, in usually they coordinate the US voluntary national standards, and then IEEE, again they develop standards. So some examples are given here: IEEE 830 for software requirement specification, ISO, again international standards, ISO IEC 12,207 for software lifecycle processes. Likewise, you can see there are some standards out there. And these matrices measure some adherence to the standards, for example, code quality and also the performance. So these are used to check the software development standards and whether they are adhered to the standards. And then once you actually design standards and matrices, one thing is you need to set tangible goals, which means you have to select appropriate matrices, and also you need to monitor progress. So these are like some crucial aspects for a project success. So you might have seen like not all the software projects are successful ones. So so for the project success, there are many things that you have to consider, but following your standards and selecting appropriate matrices or which will improve the success of a software development project. Final parts. So under this part, we will discuss about some procedures and installations. As we have discussed in previous sessions, these topics we will touch upon later in detail. But when it comes to procedures and installation, we have to define what we call measurable goals. And when you're defining measurable goals, you have to use historical data, synthetic data, and also like expert opinion on this. And then you have to maintain the balanced goals. You have to consider cost, schedule, effort, and quality. We will discuss some of these costing when it comes to discuss cost and benefit analysis, what kind of cost are there, cost classifications are there. But you know that if you want to improve the quality of then sometimes cost will be too high. So then you have to maintain, make a decision on so how to maintain the good balance, right? So these are interrelated. So maintaining a good balance might be a crucial aspect. So when we set up a goal for a project, so then it's always good to make milestones, or like what we call intermediate goals, and then you can see whether the project is reaching those milestones, right? So that's very important. Now, for example, aim could be like development and information system for, let's say, managing a university might be the major goal, but then you have to have intermediate goals, right? For example, handling student activities and the matters might be one, and then you can go with the lecturers and so on. So likewise, or it's always better to have several goals so that you can monitor the progress will be easy. Then assessment is another one. So for example, data collection. So when we, in any information system, we need to have data. Now, the data could be manual in the meaning like you need to have human involvement. But nowadays, there are a lot of semi-automated and automated methods, right? Like, for example, the tagging, and then you can have QR codes where you can actually read through barcode readers, so that by doing that you can actually semi-automate or automate the data collections. Then the data analysis also again important. So you have to perform what we call the project analysis. You can have checkpoints and you can have trends, and then you can also analyze component wise. So then comes to installation, especially in when it comes to deployment, installation approaches for software systems. So you can go for direct installation, or you can use parallel mode, which is you can actually uh, uh, replace the existing system, where once you install, you can completely remove the old system. So it's in the deployment we discuss these ideas. And then you can have phase approach. So for example, nowadays our systems are highly distributed. Now, for example, if you take software like Google Map. So Google Map is a very complex software system where you need online at the same time handling billions of users, and you will have a huge data. So implementing or installing such a system might not be possible at once. So you have to have some phased approach for going from one server at a time, maybe install it, and then you move on to the other servers and so on. And this could be even in different geographical locations as well. Right. Now we came to the place where now we talk about the old aspects of software development. But then again, as we can develop a software, but without knowing how to use them, it's not useful. So documentation, there are different types of documentations are available. Now, in general, we know that to use a software, we have to have some user documentation. That means user guides and tutorials where we learn how to use the piece of software using that documentation. So usually user guides and tutorials, they are interactive, and sometimes you have a web-based resources which actually shows you some screenshots, nowadays some YouTube videos where you know how you may use the software. And then if you look at the system development perspective, system documentation is very important because you know that software is developed by teams, and then you know, over you know, decades, there are a lot of work, right? So which means that to maintain a piece of software, you have to have system documentation, starting from everything, starting from the design to technical documentation should be it should be very important, because the knowledge transfer. So what might happen is those who have developed the piece of software might not be available when there's need of change of the system. And also the new members will become the part of the development team, and they should understand how system is developed and how to make any changes. Right. Now, if you look at you know, mobile industry, although in mobile industry you will see there also we should learn how to use the mobile app, for example, but their help is very, very simple. So for example, that's what we call in-app help, which means the help is with that, and it will be a simple you know, application where you can, it will show you like what are the importance you know, places or within the software itself. And then tool tips, sometimes when you move you know, mouse into a particular place, then it will pop up with a small message. Or sometimes you might see some question mark where you can go and click the question mark, which will explain what this is all about, which is what we call the context sensitive assistant, which means depend on where you are, it will provide you the help. Right. Then nowadays, video tutorials and screencasts are very common, like places like YouTube. You can see a lot of, you know, video tutorials are there, like how you may actually use the piece of software. Then API documentation. You know that now there are a lot of software use APIs for other developers which use the essential components of the software. So to use a particular API, you should know that how to use them. So for that, we have what we call the API documentation. Right. Then as the last point, there are a lot of collaborative tools, software solution again, for managing and handling a software itself, right? Now, for example, Confluence, if you take it, like it can work as a documentation tool. At the same time, it can be used to interact with the other team members, where you can actually assign, you know, work to be done, you know. So likewise, there are a lot of collaborative tools nowadays used, and there are a lot of documentation platforms are also there. So you can have a look at, for example, Confluence. Confluence is one of such software. And some of the companies, depending on where you are going to employ, they might use some kind of software like this to manage the software development. Right. The next part will come the maintenance and the training. Now, once the software is actually designed, developed, and deployed, the next crucial step is the maintaining the software. Now, when you say maintaining, of course, we know we have to correct any errors within the software. So when you develop a piece of software, you know, it's common that we make some mistakes. Essentially, those things should be corrected. We call corrective maintenance. So basically, focus is we need to address errors and any issues. Then the second one's preventive maintenance, right? I think we have a separate topic on this, especially when we have safety critical systems. Like let's say you are developing a piece of software to send a spacecraft to the space. I mean, you cannot, correct errors while, you sending ship to the space. So we have to prevent any errors, right? So that means we call preventive maintenance, mitigating security vulnerabilities and potential risks. So this is very, very important in safety critical, developing safety critical software systems. Then improvement maintenance, especially when you want to enhance the features or then adapting to evolving user needs. Once you develop a system, then you will get requests from the users for new features or enhanced features. So this type of maintenance we call improvement maintenance. And then change management. We can maintain a prioritized list of changes and additions, and then what needs to be added or changed that could be selected using in this prioritized list. And then if you take agile processes, I told you like in agile is more focused on continuous integration and continuous deployment, and they have pipeline for automating this continuous development and delivery the tasks. Right, and then you can use tools for tracking and prioritizing changes like Jira and Trello. Some examples where you can use software solutions or software tools to manage and the piece of software. Right, now let's focus on the training aspects. So you can actually use end user training, especially when you have a software solution, you need to provide the training for the users. You can offer web-based tutorials, you can offer interactive courses or video demos, and then you can implement in-house onboarding and tool tips to aid user understanding. Then we have support. Now, support means like when you're using a software, you can get an error. And usually what happens, we will find answers in on the internet. And there are some software forums where we can actually find solution. But now you can have assistance. The problem is human assistants are rare. And because sometimes it's not feasible or cost efficient to have a human to work for the support. Of course you can have, but nowadays with the AI development, we will use AI chatbots. Most of the now assistance, the support you will get through this artificial intelligence chatbots, right? And then for the technical support, that means general support, we can use AI. Of course, for technical support, then we have to share the knowledge share through online forums, Kiwi, and then you can use other community spaces. Monitoring and analysis, you have to, when you develop a piece of software, you have to always monitor the performance. When you say monitor the performance, now there are two folds. One is if you have your own infrastructure. That means if you have your own servers in the premises, then you can check the utilization of this. But nowadays, people can think of cloud implementation, which is very important to know the utilization, because the costing comes with the utilization. So you have to make sure that optimal utilization, otherwise you have to spend money on these resources. Then getting user feedback and also prioritizing improvement and enhancements, as that is also another aspect that you have to think in the software development. Right. Just to summarize what I have done in this lesson, the part one is we have looked at software uh, development and design, the different phases, and then the things that you need to actually focus on in software development task. Right. The next part, I would like to switch my other topic. That is part two. Right. Let me share. So our next topic, advanced software design, is use-oriented systems. Now we have discussed in our first part that the new software development methodologies focus on satisfy user requirements. So when you're designing systems, you have to focus on the users. So when you say use-oriented system, it means you have to use users from the inception of your software solution. So that means from the start, you have to involve users in the design. Now, to develop a piece of software for a user, you should understand what their business is all about. Now, for example, if you want to develop a piece of software to handle activities of, let's say, SLTC, so you have to have a good understanding about what is happening there, right? So that means you need to first understand the work of the business. And then you have to use users as a source of data. You have to get information about their work habits, the loads, at the same time, the performance requirements. Things like, okay, how many users you might expect use your system at the same time, right? Then third, you have to keep up the user needs together with the technological changes. There are changes in the technology always evolving, and you have to remember that you have to keep always the user needs. So you can utilize agile methodologies for user environment. So that's why one of the reasons why the recent software development, we focus a lot on agile methodologies. Now, when you want to focus on the user-oriented, designing user-oriented systems, the two things you can think about, you can use user-centered design, in short we say UCD, and you can use human-computer interaction, or HCI. So if it is an agile process, we talk about in agile, there are various phases. So you need to engage users in design in sprint, as well as prototyping, which means they develop software components. And then you can leverage data-driven design techniques. So to maintain a healthy development process, you have to foster collaboration with DevOps and continuous integration, continuous deployment. That's what we discuss. And you can use different user testing strategies, A/B testing, and then usability test. Then you can collect user feedback using analytics, surveys, and interviews. And you use those user needs using iterative and incremental development practices. So let's try to understand what these UCD principles are, user-centered design principles. Now, remember that when you are developing a software, you are catering a user in mind, and you need to understand their needs, their preferences, their context. So normally what happens early days that you design everything and you give this to users to work with. Nowadays it's not like that. We incorporate users from the beginning, and we try to understand what they need and what they like and not, and so on, right? So once you decide on their needs and preferences, the context, you have to clear measurable user goals and objects. You have to establish clear and measurable user goals and objects. And remember, you have to always think about when you are designing, you have to design with accessibility and inclusivity in mind. So what you should do is you should involve your users throughout the design process. Throughout the design process, you always get feedback with the evolution, right? And especially when you're designing user interfaces, you have to prioritize for simplicity, consistency, and intuitive interfaces. So I hope you already know that when you design user interfaces, not to use a lot of colors, not to use a lot of fonts, and then you will have consistent user interfaces, things like that, because we want to make it simple, consistent, and intuitive, meaning like they don't have to spend hours try to figure it out how to use a piece of software. Right. Human and computer interaction, or SAI principles, we need to ensure effective communication between users and the system through clear visual design and feedback mechanism. So I will come to visual techniques after finishing this part. Then design interfaces that support user mental models and cognitive processes. Depend on how they think about something, you need to design the interface. Provide efficient and flexible interaction methods, accommodating different user skill levels and preferences, how they actually interactive with the software system. So sometimes you can think of, depending on the technological advancement, like maybe how you may actually handle keyboard, mouse at the same time, the touch screen. Then prevent errors by designing robust systems and offering helpful error messages recovery options. Remember, like, for example, when you enter in data into a form, you will get some error messages you cannot send without the way they want. So that is very important, because what you collect is, if you make mistakes there, if you are not making sure what is there, so that might be a problem at later stage. And our focus should be strive for user satisfaction, comfort, and enjoyment in the overall user experience. So remember that this is very, very important. Right. Now we talk about A-B testing, A-B testing, right? Method for comparing two or more versions of the design, feature, content, or determine which performs better. This is very important, especially with the users. Now the problem with the user preference might be different. And to understand what they look, and whether what they look is whether what we are trying to deliver. So you can have several versions of the design, even for the user interface. Let's say you can have, not to have too many, but at least let's say you have compare where they could be satisfied, because you are not giving just them one choice, but you give a two choice. They can think, make a decision. So A/B testing could be in different places, like it's like you presenting to different versions to users, right? And we will also have what we call KPIs. So access success of each version. So then we can going to decide which one you are going to select. Now, for example, what places you can use A/B testing? Web page layouts, button colors, email subject lines. So these are like some of the places where you can actually use A/B testing, right? And you can use statistical analysis to determine which one is the winning version and which then you can actually implement. Right. Next, the usability testing. So usability means how usable your developed components are. So that means you can think it as a method for evaluating the effectiveness, efficiency, and satisfaction of a product or interface by observing real users as they interact with it, right? So that means you provide them and then a set of users and then you get the feedback. So usability testing actually can be done in various stages, right? Not necessarily at the end of the development session. And then you can also use different types of usability tests. We can have moderated, which means you can have it as in-person or remote, unmoderated, and then you will also have things like think aloud protocol. Then you have testers provide qualitative and quantitative feedback, which is used to identify issues and area for the improvement. Qualitative means it could not be measured numerically, but and quality wise, right? Sometimes when you look at the development aesthetic aspect, it may be qualitative, but the other one is quantitative, right? Things like how accurate your predictions are, right? So then quantitatively, you can give a feedback with a number, for example, and then these guides usually guide for iterative design enhancement, so which will later uh, affects the or improve the user experience. Right. Combining testing strategies. So as we have already seen, A/B testing and usability testing is different purposes, but then you can provide complementary insights. So A/B testing, as we have already seen, so we will select based on the different, as you are going to select one of out of provided outcomes. And then usability testing is overall user experience and interaction. So the suggestion is you use both, right? So you use both, which means the product is, we have to make sure it's not only effective, but also enjoyable and easy to use. So you have to make sure everything is there, right? And then to do that, you can actually conduct regular tests throughout the design and the development process. And then you can have continuous improvement and user-centered design. So iterative testing helps to create products that resonates with the users, leading to higher user satisfaction and engagement. Sometimes you can see this, for example, sometimes let's say take a game, for example, you might find some games are more attractive than the others, right? Same game logic, but then you might prefer one or the other based because the main thing is the user satisfaction and how engaged they are with the product. Right. Then when you want to change the system to for the requirement of the end users, which we can say tailoring systems to end user needs, so we can emphasize user-centered design or UCD, and then also human-computer interaction principles together with the agile methodologies. And we have cross-functional teams for better collaboration with end users, continuous feedback and iteration-based end user input. And you can apply design thinking to understand and emphasize the end users. So this is what we need to think about the user-centered design and human interaction if you take two principles together with the agile methodologies. Okay, final part for today. Now, what are the consequences of ignoring end user needs? Right now, for example, one of the case studies from the book is New York Stock Exchange, and their engagement were lacking with the users, and what happens, it leads to an incomplete system. So which later they have to spend more cost for enhancing the features that they need. So this might happen. So sometimes if you just implement something, and then if you not incorporating the users might not like uh, uh, the product, and they may actually request the enhancement which you need to spend more money on enhancing the features. The second case study is with the Swiss bank, and then what happens there is the IT department, they have not considered the user requirements. What happens, outside consultant, they deliver successful team, right? So this leads to actually taking IT team out. So they have replaced, because IT team, they didn't meet the user expectation, right? Therefore, remember, so you always need more on user-centric systems and solution. Without that, you might not be able to survive, right? So sometimes you can see people select product based on their satisfaction with the software solution, especially maybe banking. But if you look at the banking solution, sometimes you feel that, okay, you are more comfortable with one banking solution with the other, which leads to switch the banks. So remember, it's very, very important that you think in users' perspective, right? Because now we have a very competitive market, and there are similar products everywhere, which means we have to compete each other. So if you want to get an edge from this competition, you have to always think about the user and also the design principles. Right. Key takeaways. We can say that by discussing the ideas that we have discussed in the couple of slides, building system, we need to tailor to end user needs. It's crucial to success in today's fast-paced environment. And IT teams should actively participate in user meetings, immerse themselves in the customer's culture, utilize modern technologies and principles to create user-friendly system that adds end-user needs. Failing to prioritize end-user needs can lead to costly consequences, damage reputation, and loss of competitive advantage. Right. Okay, so I would like to stop at that point because I would like to continue the other part with the new topic. It's about designing user interfaces, which I will discuss in the next class. So next Tuesday, so I will provide some basic understanding about the user interfaces, and then during the interactive session, we are going to create a user interface which follows, appreciate the ideas that we have discussed in the previous sessions. So with that note, I would like to conclude, but I would like to clarify any issues if you have.